Shake Table Lab by Christian Park and Austin Kim. Austin's and my building sketch has all the measurement goals for our tower. We were supposed to have the first floor 18 centimeters tall and the second floor 18 centimeters tall, making the whole building 36 centimeters tall. During the first part of the construction, Austin and I started with the base and doubled the straws leading up to the apex of the tower. We started on the first story and taped the shape of the first story to the corner straws. Our first period was completed. Here, Austin and I attached the cross supports on each side of the tower, making it sturdier. We also added the roof, or the second story, and a cross support at the top of the tower. We added extra tape to support the straws. This was the end of our second construction period. After we finished the second construction period, Austin and I added paper to the first and second stories. Then we decided that we needed extra support in the middle of the base, so we added a straw for support. Austin and I had finished construction period 3. Austin's and my completed tower has an interesting roof and a rice and noodles flag, putting in some design and creativity to our tower. It is tilted to the left, giving it a unique look from the rest of the towers. Our tower also has a small skylight in the top for the sun to get onto people who want it on the roof. Looking at this picture of the real dimensions of our tower, we can see that the height of the first floor is 18 centimeters, the height of the second floor is 18 centimeters, and the height of the third floor is 17 centimeters. Including the roof and flags, our total height is 81.28 centimeters. The width of our roof is 19 centimeters, the width of the top of the second floor is 21 centimeters, and so is the width of the top of our first floor. The width of our base is 26 centimeters. Austin and I did many static tests, and this was one of them. I believe that the tests were successful. Our tower didn't collapse or fall in on itself, and the sandbag stayed in the same position for over 20 seconds. Austin's and my tower was strengthened by the double straws we put on the corners and the cross supports that we had on the side. The tower was also strengthened by the straw in the middle of the base holding up the first story. I think that I had a lot of strong parts to choose from in our tower, but I decided to choose the cross support and middle bar in the tower. I think that this is the sturdiest part because it has the most support from straws and has double straws in the corners, putting in extra sturdiness. Austin's and my weakest part was the top, where we used many straws but barely any of them were for support. We needed to add design, and the top didn't need any sturdiness to carry the weight of the sandbags, so we decided that we would use many straws for design and not any support. Many people, including Austin and I, believe that we used an excessive amount of tape for our building. Rat's nest syndrome was all over our building, but Austin and I decided that we were better safe than sorry. We put in enough tape to support all sides of the building, and we think that more than enough tape wouldn't make our tower any weaker. The extra supplies that we acquired all went into the roof design. Austin and I used the extra supplies to design the wedge-like slanted rooftop and the skylight for sunlight to get to the third floor. We also added rice and noodles flags to our tower, making it the most beautiful tower on all of Earth. This video shows our tower on the shake table with 12 sandbags.
Why are you doing it harder for us?
Oh!
Oh!
Wow, you guys' tower is strong.
Oh
How?
no, it broke! It broke!
It's good!
Yeah! Yay, Christian!
Add 2 more.
Oh my God!
Guys, good job.
And that guy.
Is that 100? 87.
I think you're up to.
Our tower collapsed at 14 sandbags. This is a slow motion video of our tower collapsing.
That tower too.
This graph shows the x-axis, which is the side-to-side motion, the y-axis, the back and forth motion, and the z-axis, the up and down motion of our tower while it was on the shake table. Hello, my name is Christian Park, and I built a shake table tower with my partner Austin Kim. Our tower held 12 sandbags, which are 450 grams each, and it collapsed on the bottom left corner and the middle straw support, and they bent, and the weight was too much, so it collapsed. If I had more straws, I would probably add supports to the middle of the tower, because that was where the straw bent, and we needed more support there to carry the weight of the sandbags. I learned that making a shake table tower is very hard because you have to get the exact right measurements, and if you don't, it has a high chance of collapsing. I had fun with my partner Austin, collaborating and using teamwork to build our shake table tower.
Hello, my name is Austin Kim, and I built a shake table tower with my partner Christian. Our shake table tower held 12 weights, which are each 450 grams. When we put 14 weights on, it sadly collapsed. The first part of the building to collapse was the side beams that fell and bent. The whole tower depended on the side beams, and when they broke, then the whole tower collapsed. If I had more time, I would have built stronger side beams to hold up the tower and support it. My favorite part about this project was working with my partner Christian, because we got to decide how we wanted to build the tower and how we wanted it to look. In the end, I was really proud of our design. I learned that it is very hard to make a tower that is earthquake resistant. Architects must have a really hard time building because it is very difficult, and being able to make a tower to support weight as well as survive an earthquake is a real challenge. Thank you.